Algo Ace 2.0 Session 4, organized by the IEEE Computer Society Student Branch Chapter of University of Sri Jayawardhanapura. Before we begin, we'd like to sincerely thank our annual silver partner WSO2 and our annual bronze partner Omega Line for their valuable support throughout our initiatives. This initiative is conducted together with CENSOC, the Computer Engineering Society, SET-IT, the Students Association of Information Technology, ICTS, the Information and Communication Technology Society, CSA, Computer Science Association, and ICTSA, Information and Communication Technology Students Association. Today, we are continuing our structured journey focusing on recursion, backtracking, and graphs. Algo Ace 2.0 is all about improving how you approach problems. Not just coding, but how you think, break things down, and actually solve them. Now, just to give you a quick idea of how this program runs. Across all sessions, learning is always followed by application. After each session, there will be a quiz based on what you learned during the session. Since this is our fourth session, you will have your fourth quiz today, which will open right after the session. At the end of the program, there will also be a final quiz covering all the topics discussed throughout the series. After each quiz, we will share a leaderboard so you can track your progress and see how you are performing throughout the program. Your final score will be based on both consistency and performance. 60% comes from the 4-session quizzes and 40% comes from the final quiz. And based on your performance, you will be earning shareable digital badges. That includes Apex Performer for the top overall rank, Distinction Performer for top performers, Consistency Performer for those who stay active throughout all sessions and quizzes. Alright, moving on to today's session. It's my pleasure to introduce our speaker, Mr. Madhushan Ilangakan. He is a former senior lecturer, an IEEE VLT graduate, and an award-winning NVQ lecturer with extensive experience in ICT education and academic leadership. With over 9 years of teaching experience, he is passionate about project-based learning, educational technology, and empowering students through practical learning experiences. He has also made significant contributions to the IEEE community, serving in roles such as STEM outreach leader. We are really glad to have him with us today. Please join me in warmly welcoming Mr. Madhushan Ilangakan. So, without taking more time, I'll hand it over to him. Over to you, Mr. Madhushan.
Yeah, thank you. Wait, just give me 1 second. Okay, is my screen available to you?
Yes, sir.
Okay, thank you again for inviting me to conduct this session. Previous year, I also done the first session, so glad you have back. And so, first of all, like I was asking questions like before starting this lecture. So this is not like a lecture, like this kind of a session. And thank you again, Japura, Algo Ace 2.0 to invite me. So I was asking like, which programming language is better for Extreme? So definitely, I know you will go with most probably Python. So majority go with the Python, and that's sure. Like the actual part is sometimes Python is not the better language. So my series start with the like some sort of like space and time. So once we learn this kind of stuff, like there is no proper language to face IEEE Extreme. It's depend. In the most cases, Python is the optimum way. But in some cases, like you can use less time and less space by using another programming language. Think about that, like when you are going for a top competitive, it depends on like 1 millisecond. It all depends on the 1 millisecond. So let's start our session. So introductions is like today I'm gonna more talk about like what is dynamic programming and why we need dynamic programming and where we use like dynamic programming and how we use dynamic programming. With those stuff, like I am talking about 4 examples, and I already like I think I was given my collab sheet to share. Damditi will share with you guys my collab sheet. So going to with the collab sheet, so you can try out with me while I'm doing practicals and theoretical stuff. Again, that is totally fine. Like since we have like first year students, like there are several department students and foreign students. So like my speaking level more aligned with like the first years to third years. Like I'm talking with in the middle of part. So I think you can learn more stuff from here, even though I will be share all the lecture materials with you. Okay, let's go for our topic. So what is dynamic programming? That is the question. So I know you also can do programming, like you know basic stuff. Why dynamic programming? That is the question. So basically, in the previous time, like we can able to make a proper like we can make a proper structural program like this. Print this, like that is go like as this. But the thing is, like, for example, if we need to print 10, like assume print 10 stars, so we need to write 10 stars. So that is the oldest way. That's like a minimum oldest way. Anyone can do that. But what happened now? So the previous day, so when they got a like very larger scale complex problem, they think, okay, we can sort out. We need to divide it into few parts and we need to isolate few parts. Then we can come up with a better solution. So that is considered as some sort of a divide and conquer technique. Yes, dynamic programming, we also doing that kind of stuff, but we are avoiding isolating stuff. So when it comes to the dynamic programming, like we get the questions, we get the whole question, but we are trying to find out how they were connected together, how to approach to these questions. So like some students are things I don't have much knowledge of programming. So when it comes to the dynamic programming, like programming knowledge is like you need some sort of programming knowledge, but programming knowledge is not high essential. You need to think. Sometimes for the one question, for the one problem, you may have 10 to 11 answers. All are correct. All are giving the actual values. But what happened? The thing is, like, some programs take a lot of space. Like in the program run, it takes a lot of memory space, of times to execute. So to avoid that, we need to find out the better solution by using dynamic programming. So today we are talking about few techniques by how to use dynamic programming and those stuff. But even though we are talking this stuff, some students like some students, I think, like we cannot understand. Yes, okay, we know now. Okay, after at the end of the lecture, they think, okay, I know this kind of technique. But the thing is, you need to more practice. Like without practice, you cannot do stuff. If you practice this kind of a questions, like when you're getting another questions, you will see the small part related to your previous question. To be a better dynamic competitive programmer, you need to practice a lot of questions in a better manner. So in here we will discuss few examples, but like in the internet, there are a lot of examples. So, okay, let's move on for the next slide. So we learn about dynamic programming, sort of. And why dynamic programming related? Actually, our topic is very large one. The topic is inside the dynamic program. So why? As I mentioned before, why is all about the space and time. You will come, but it's all about the space and time. So now you will see the time complexities. Like some students are not familiar with that. Like there's like, oh, these are like, like Freddy's hair. These are the green. You can think as like that, but eventually we will learn in this lecture. So some sort of programs we need to think about the time and the space. I will share this kind of things with you. And again, like this, you will learn this part. I'm skipping this part. It's like rather than talking stuff, I think it is better to go with practical stuff. In the practical, by doing the practical, definitely we are learning this stuff. Once you get in the presentation slide, definitely you can use this slide as well. So in the dynamic programming, basically we have two approaches: top down and the bottom up. So top down mean like we think about the problem and we sort out the problem. Somehow we are going to sort out the problem. Then in the top level, we are looking, can we separate few structures or few sections? So that is the top down. And when it's come to the bottom up, it start with the earlier stage, like it begin with the problem start. So eventually it will sort out the problem. So within this session, I was planning to talk about the recursive method and the memorization tabulations and the few part of the space optimization. So these are the things we're gonna cover up. So still, I was done my introduction session. Like this is the flow of today's session. So let's move on for the next one. Okay, this is the major thing. Now you learn the names, only the names. Huh? You will do the practicals. Now you learn these kind of words. There is a recursive, there is a memorization, there is a tabulation. Can we use all of together to a one single question? If it is can, it will be better. Like in the most appropriate, most cases, you cannot. You need to find out which solution is better. For some questions like top-down approaches is the more suitable approach, but when it comes to the some cases, and the bottom-up approach is the most probably the beta phase. Okay, we talk about all of the thing. I think now you got. I think the group shared with the collab. You can open the collab. You will see like this. I will give 1 more minute. You can open now. So you sharing the Google Drive, but you cannot edit. You can download them. So I'm using Google Collab, but you can download it to and attach it to your account. But I will wait like another 1 to 2 minutes so you can preparate with that. So this will be a really fun activity. Don't think this is like a lecture or some kind of thing. So I will wait like 7 till 7:24 so you guys can like open the collab. While you guys open in the collab, like really like next year, the previous year, University of Jaipur have a lot of participants for the IEEE experience. So in this year, we will see like more than the previous year. You guys can participate and just finish. Like this is not a coding, huh? Just think about. This is using brain, but without practicing, you cannot use your brain. At least you need to see some kind of a similar question. Otherwise, yes, definitely it can, but it takes a lot of time. That's why you need to practice with the questions. Okay, time's up. I think we can start. I think you have a little bit, since you are come from the IT graduate, like majorly come from the IT background. I think you are a little bit familiar with college. But like these are my few examples. You can see. So I think you like most of the guys say like your favorite language is definitely I know you will say your favorite language is Python. So because of that, I was going with the Python. So I think you will see this is a function. I'm not going to like talking about the basic stuff. So let's run this function. So we can type 7. So what happened in there? So it is show to me like how long does it take to run it within my environment. Okay, I got it. How long does it take? It is good. Like with the 0 seconds, we got it. So what I was done? Like I need to print out 7 to 1. So this is not a what? This is what? This is a function. I use function. Like rather than going for an iteration, why I was using a function. So this is a part we need to think. Eventually I will come to that part also. So thing is like the function will run this the calling runs if it is this it returns and this function calling the functions. So this is calling again this function. This is some kind of a recursive. So you can use this technique rather than going with the iteration. So it is better. So what do you think about? Can we try like 3,000? Sorry, 300? Definitely. Yes, running time is 3. Other than that, so you know about the code. Now I'm going to type. So I in range 300 print I. Again, this is also good too. Let's move on further. 3000. What happened there? I got an error. What did he say? Maximum recursion depth index. Definitely it is fine to get a like 300, 200. These are definitely. Yeah. Oh, okay. Let's see, check with this. Okay, 300 is working well. Just let's put 3000 in here. Now I can get the values. I can easily get the value. So even though I was using the calling function within the function to this scenario, but by using simple for loop, I can print those values. So what now? What is it like? I was saying like because it is good, but now what happened? That in some sort of case, like using all the dynamic programming strategies is not the optimal thing. You need to think about it. You need to think about how you're gonna use the space and the time. But recursive is good. Today we are learning all this stuff. But you need to use is the proper locations. Otherwise, what happens like you using it because of that you get runtime. Normally, like your running time will be stops. It's not your programming error. Okay, so forget about that. Again, now we are going to go with the. Okay, now we are going with the same thing. So assume I need to get the, for example, even numbers. So simply you can type 3. The same thing. But this thing is calling a thing. This thing is calling a function within the function. This is the basic concept of the recursion. Okay. Now let's go for a like little bit. This is not a harder thing, but what happened in here? The same thing. Example 3 is the same thing. What happened? These these the one. These the row. The program will be called. The function will be called fun3. So the 3 will go for this, and definitely it prints 3. Then it check n less than or equal 1. So definitely it will say return. Now what happened? Fun minus 1 is calling. So in manner, what you think? The output will be. This is calling the function within the function. So go again in here and it printed. How it print the one? Again, you can see the voice print here. But how it happened? So these are the small things you need to know. This is it. In here, we are using two functions. So these two function calls recursively call the function. But how you gonna use? That's the thing you need to learn. If you think those values are incorrect, I can run those two. These are the things you need to practice. Okay. While you think about that, I will move on further, like the presentation material. So now we learn few things, not all stuff, few things regarding the recursion. Still, we know like calling the function, within the function. This is the recursive, but that is some sort of right, but you have the basic idea. Eventually, we will come to the memorizations and the calculations. So, okay. So, we will start in here where to use dynamic programming. And this is some kind of a, like, you consider this as like, this is not a rare problem. These are like very basic level problem for dynamic programming. Definitely today we're going to discuss more about the Fibonacci sequence and this kind of questions. Like, again, the native method and like edit distance, like minimum operation. These are the like, uh, today I was getting these questions because of like, these are the like, these questions are very, very familiar for the most of dynamic programming interested people. So you guys can find out more from the internet regarding this question if you have like few doubt of that. At the end of the program, definitely you can ask the questions from me, but this is not the thing you need to like, yes, I know this kind of stuff, but these all are come from with the like some sort of experience. Even for me, some questions are very hard. That's totally fine. Totally fine. No one is perfect. You need to know this kind of thing. You need to see this kind of thing, this kind of technique. Then you can apply it for the questions. Okay. So let's wait for the famous Fibonacci questions under the how to use dynamic program. So this is a first example one. Write a function fib. You can say whatever you like. Just write Fibonacci command the fib. That's right. Fib that taking a number as an argument. The function could return the n number of Fibonacci sequence. So still, it's okay if you don't know what is Fibonacci. The first and second number of the sequence is 1. I have a hint. To generate the next number of the sequence, we sum you can think. Okay, this is the Fibonacci. But I will go for a fun fact. This is the Fibonacci. This is the original Fibonacci. So it means like it is starting with the 1. 1 plus 1, 2. Again, 2 plus 1, 3. 3 plus 5, we call it 8. 8 plus 4, 13. So again, this is for like a spiral way. Like these kind of techniques are used like some sort of process, Darwin use this kind of. That's been really interesting part. So you can like Google like how Darwin use Fibonacci. And this really interesting part. But in here, like we need to know these are the Fibonacci sequence. So 1, 1, 2, 3, 5, 8. Sort of you can get numbers. To identify those stuff, so I was put like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So let's move on for this. Before going to that, I was talking about the differentiate between the recursion and the iteration. The recursion and the iteration. So now you can see, like, you know, a little bit recursion and what is iteration. So we've done the iterations, like to print out the first 300 numbers, like this, by making a loop, for loop. Definitely we can put a thing. What? 300 for the 300. Okay, for loop is the fastest one. What happens if we going for a 3 billion? Like, in such a manner, for loop takes 4 billion, some kind of. Now, in that case, if we use better dynamic programming, we will do it very easy. Very easy. That's the beauty of dynamic programming. So majorly dynamic programming you will see as a tree, like sort of tree. You will see, I think, you, when it comes to the like CS, basic CS related stuff, you will learn trees, heaps, and maths. So like these are the basic trees, but don't worry, we will come to here. So think about this. We have the recursions and we have the iterations. But the major thing is you need to use the optimum solution. As I mentioned before, some people say recursion is the best. No. Sometimes the iteration is best. So on the request. Okay. The white mean we need to go to the our color. Okay. Okay. So since we completed our third program, let's come up for the fourth one. This is similar. Okay, we done the fourth one. Okay. Let's identify what is recursive. For the previous question, they gave us a hint, I think. They gave us a hint. What is the hint? To generate the next number of the sequence, we sum the previous two. So it means like, yes, we can sum together, sum the previous numbers again. We can, yes, we can sum the previous number and print the current number. Definitely we can. So what I'm going to do the same method. Whatever. I'm gonna type 3. Let's see. Even though I cannot get those. I know why. This is for you guys. You cannot do in that manner, but this is for you guys. Because this is maximum. It is doing the recursive, continue recursive. That's right. But this is for you. So before going for the recursion, I think you familiar, but I was saying in the previous one. How you're gonna print those stuff. So let's print the first Fibonacci number. Definitely it print 1. So how this work? This is working like it means the n is less than or equal to. It means like first number and the second number is 1. That's why we return it. It means like someone enter the 1. It also return the 1 because the first iteration is 1. Again, that's why I was going with 2. Still cut off. Again, it showed 2. Okay, what about 3? Now what happened? Now it come to 2. So these are the few things you need to practice. These are the few practice. Still we are not come to the original questions. You need practice. How the recursive work. Again, this is for you guys, like some sort of thing. You can find out what was happening in here after the session. So now we come to students. Okay, this is the actual code, but this is not the ultimate better solution. But this will give you the output. For example, in the chat, like give me a number so we can find out what is the Fibonacci number, like first, third, but don't go like highest numbers. Can someone type? Now a chat. That's the chat. Yes, I got it. Can someone type? Okay, 9. Very good. Thank you. So we can type 9. So in here, I'm going to find out the 9th one. So the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 30. Okay, should be 34. Definitely this one. Okay, this is a good solution. Oh, you will see. So how it happened? In the question, I think you have get the hint. To generate the next number of the sequence, we sum the previous two. It means what? If we given the nth value, so what are the previous nth value? Like n minus 1 and the n minus 2. So we need to sum both together. So that's why the return function, like return, is like this: equal or less than 2, return 1. It means like the first two cases, definitely it should be 34. So it should be 1. So, okay, thank you again for typing the 9. Can we get 90? Please check. That's why it's perfect. Huh? You can get like the 11th one. This is not wrong. Huh? This is totally right. Yes, definitely you can get. Can we get 90? Let's check. Now what happened? Let's wait. This is not because of the internet law. Because this happened because of these functions called the functions within the function. But definitely we can get the answers here. Definitely this is the answer gives the right thing. But the thing is, this take time. You don't like even the 30, I think some sort of time it will take. Let's wait till it's come. We can we will try to identify how this happened. So by connecting first two numbers, 1 and 1, so you will get 2. So for the next stage, you need to connect like second and first number. These are the numbers. Huh? Then you will get 3. So now you need to find out the third one and the second one. It will be like 3 and 2. How to make 2? It will be like 1 plus 1. It's 2. 2 plus 3, 5. Now what happened? Like we need to sum. So again 1 plus 1, 2. 1 plus 2, 3. Then the 3 plus 5, it becomes 8. We'll come to this. Just think about this. I think this will be more suitable for you. Like first one and the second one, you can sum, then you get the third. So to get the fourth one, you need to get sum of third one and the second one. To get fifth one, you need to get sum of fourth one and the third one. And to get third one, you can get the sum of second one and the first one. And to get sixth one, you need to get the sum of 5 and 4. But to get 4, you need to get the sum of 3 and 2. To get 3, you need to get the sum of 2 and 1. Again, to get 7, you need to get the sum of 6 and 5. To get 5, again 4 and 3. To 3, in here, like I was done a few mistakes. So one of these should need to be 1, considered 1, not 2 and 2. So I think, okay, are you happy? Still the 90th value is running. I will stop this. So what about 30? Let's put it. Okay, 30 will run, but when you come to the 90, it will take a lot of time. So I think you see the pattern in here. Like, wait. You see these pattern. 1 plus 1 is 2. Again, 2 plus 1 is 3. These things will connect to this. And these things will connect to this. And these things will connect to this. So we don't need to create the same value again and again. But in the previous time, we created those values. That's why it takes a lot of time. Even giving the answer, Now, when it comes to the dynamic programming, the solution, like getting the answer is not the ultimate thing. You need to think, as I mentioned before, you need to get a correct answer with less time and by using less RAM space. These are the things. So I think you got the idea. So yes, we have an, just give me 1 second. I'm going to clear our drawings. So definitely I have this one. Definitely this one gives the answers for me. Now I'm saying, I was not saying in the previous two, this is not the ultimate solution. So this is the, let's go with the smallest one, 9. Don't think about the code. 9. So it's a 34. Like we lost to type in 90. Let's check. It gives the answers. It's a lot of, it's a very big number, but it gives the answers. So what happened there? What happened there? The thing is, as I mentioned before, we are memorizing. This is the second technique, memorization. We are memorize these values. We are memorizing this value. When this value is need, we are replacing that value to here. Again, we are going to replace this with this value. That is why the memorization is most important. It's like when the programming is running, some sort of part we need to use recursively in future. So in that manner, we're gonna use memorization. You got the idea. Let's go on for the code breakdown. So what is the code? It's very easy. Again, you will see like this. This is the same thing. If the n value is less than 1, so it's return 1. So in what happened in there, rather than calling a function, rather than returning a value called fib n minus 1 and fib n minus 2, what happened? I use the word memo. It means like very small memorization. By using that, it is easy to get any value. Definitely, you can get the 1, 2. Again, the second one is also 1. Get very easily. Now you can get, let's check 9 outputs. This is a big value. But with 0 second, you can get those values. This is the power of power of like this. You know this is the recursive, but recursive with the memorization. Again, like when you find out these kind of questions, you cannot very easily you cannot find out where's the recursive part, where is the memorization part. Like you need to come up with the experience. Don't worry. There are a lot of questions, even the IEEE experience providing few categories, experience and like in University of Japura, they will conduct few hackathons like related to the extreme. So get the idea. It doesn't matter you will get 0 mark, but you need to learn some. Then in the next step, you can apply. Very like it's very interesting, this kind of a topic. I really like this kind of stuff. And I hope you guys like too. So let's go on for the next one. So we got a, now this is the code. related to the example 1. Okay, we done one example. We done it. So what happened here? So like you saw the tree structure. So the previous question going with the tree. So now I am trying to go with the square size, we call this as grid. So majorly we can use 1D grid. In sort of cases you call it as arrays. When it comes to the Python you call it as list. But these are the one-dimensional grid. And in here we are going to use two-dimensional. So what is the question in here? Say that you are a traveler corner. Don't worry, you get an image. Top left corner, top left corner. And your goal is to travel to the bottom right corner. You may only move down or right. So in how many ways you can travel to the goal on grid with dimensional m into n? So what is m and n? Like basically, normally one will be a column and one will be a row. Like when it comes to the like rows and columns, like, normally we get the first number as a row number. So m into n mean you have a grid. You have a grid like this. So this is your starting point and this is your end point. You only can go down or left. How many ways you can use? So here I will. This is this kind of like, this is a simple grid. So you can type in chat. So how many ways you can go to start to end? You only can travel to down and left. If left down, that is fine, but only okay. I got the one. Very good. Yes, very good. Dinuka, very good. Direct message, but others cannot see. Thank you, Dinuka. This is really good. This is very easy. You don't need to program it to do that. Just like one, like left, down. This is the first. Left, down. The second one, down, left. So what will be the third one? Left, down, left. Beside that, you don't have any other choices. So for the tree by tree, you can do it really easy. People are thinking like, okay, so why we need to sort out this kind of problem? Is they applicable for the real time things? Like, you know, like there is a way Google Map find out what is this is not they are not this method, but they also using the data structure to find out the optimum path to travel. When it comes to the Google Map, like sometimes the shortest path is not the optimum path. Sometimes the shortest path have some kind of a traffic. So there are a lot of data and there are a lot of routes. So how to give the optimum route for the user? Definitely they are using the data structures. Okay. You can start with the simple thing like this. Okay. Let's move on for the next one. So I was adding those stuff to you, like as I mentioned before, only 3. So right, down, down, right, down, right. So what happened? But we have to think about that. Now we're gonna think what happened if the grid is like 5 rows and 5 columns, and what happened it have only 1 column and 1 row. These are the things we need to think about. Like, is there any grid can have 1 column and 0 rows? That is not possible. The answer will be 0. Even though like answer is not the 0, but we need to show somehow that is wrong. So that's why I was taught like 1 and 0 or the 0 1 is not possible. It means like only 1 column, no rows. Or only 1 row, no column. This cannot be happen in a grid. So in a 2D grid, 2-dimensional grid. So definitely I need to think about this. So this is can consider 0. And this is another special case, like 1 column, 1 row. There is no proper way. They don't need to go like left or right. They are in the same thing. So we can put 1. These are like, we call these as few base cases. So when it comes to the dynamic programming, we need to find out like, we need to separate few special cases and the base case. Normally the base case will be developed going through the till the find the correct answer, the base case. But some case, rather than the base case, you will have few special cases. So in here, this is a special case. Also, this is a special case. Okay. I think you will be a little bit confused what I was writing here. So you will get like this. This is a path. You will see it. So this is the path. So there is a grid travel called 2 to 3. So 2 to 3 mean like it have 2 rows and 3 columns. So it is start with the 0 row and 3rd column. Like you will get like this, but I will come to this after the end. But I think we will be confused for this for you. I think this one is right. I think first one is you need to go down, down. Yes. Oh, I was forgot to mention like this is a tree. I was forgot to mention this is a tree. Like this side is mentioned as down and this side is down and right. Those topics like it will be complex. So think about this. Like down is for the left side and right is for the right hand side. So that's why I was going as this. So the first one is like down, right, down. This is the first case. And the second case, right, down, right. Again, you can get a case, right? Down, right, right, likewise. You can think about the more cases. But in here, you will see, you cannot think from the starting perspective. Like you don't know, like the previous time, like we know, okay, we know, like this is the base case. This is the one is going to recursive. This function is calling. So, but in here, but we cannot see this kind of stuff. So in that manner, we need to go down to bottom. That's why I was at the beginning, I was saying like each dynamic programming method is not good for the each scenario. You need to find out which scenario is the better. So if you find out those stuff, definitely you will identify these are the way you need to travel. So right, down, right, down, right, down, right. You can use this one to get like more information. You can practice with that. These are the indexes. I use it. The indexes I will write down what are the locations. So you will get that. So it means like there are 3 columns, 0, 1, 2, and these are the like 1 values. Okay. Okay, let's come to the coding part. So now you have the idea. It means like there are 2 things. First one is number of row count and the second one is number of column count. And we need to think about like how we gonna match that. Remember, we had special 2 cases. I think you remember. If the M is 1 and the N is 1, either. If both are 1, it means it need to be written 1. Only 1. It mean like either. It mean like we no need to move, but we can treat it as a 1. And we have a special case. There is no possibility to have a, doesn't matter what is the row number, you cannot have the column value to 0. Or doesn't matter what is the column value, you cannot have the row value 0. So these are my special 2 cases. That's why I cannot construct the base case related to this special case. That's why I was returning those. Rather than that, this will show. So let's check. For example, assume we have 2 by 3. I think the same thing happening here. I think 2 by 3. It means like only 2 columns. Again, we show the 3. 3 by 2. It must be 3. Doesn't matter. The same thing. So the same structure. So anyone have an answer for the 3 by 3 rather than running this? So use your ultimate brain, but you don't need to use the brain to get the logic. Like anyone, what will be the output? Like it will be 3 by 3. It means like you have 3 columns, you have 9 columns. Let's get the pattern. What will be? You will get 1 by 1. Definitely you will get 1. Like this kind of programming is all about the pattern recognition and the identify what are the small parts. So for the 2 by 2, you will get 2. For the 1 by 1, you will get 1. For the, so what will we get 3 by 3? Still I didn't see the answers. The answer is 6. So we get 1, then 2, 2 by 2 is 2, 3 by 3 is 6, not 9, but it is 6. So what do you think about the 4 by 4? Think about the patterns. It will be the output for the 4 by 4. 1, 2, 6. But these all are the patterns. And there's a relationship between the, like, these are special case, like these are the square grid. So this is like, you get 1, 2, again, and 6. You can find out the patterns. By using the pattern, you can find out what will be the 5 by 5 2. So try it, yes, like, a little bit late. I get no. For the 4 by 4, it should be like 3. But yes, you have not. Thank you again. So it's really interesting. Doesn't matter whether you give the correct one or the wrong one. You need to explore. That thing is really hard. But the beauty is that you can identify the patterns in it. You will see like a lot of trees in here, but this is the thing. This is the way we're gonna find out the solutions. Okay. So yes, very good. Thank you. So now we have the solution. Okay, we have the better solution. Now this is correct. Can we go for a, like, since our 9 by 9? Let's check. Yes, we can go for a 9 by 9. So this is good. Can we go for a 90 by 90? Some sort of good, but what happened? Now again, for a smaller problem, this is good. Okay, this is for a small problem. But the thing is, this is not optimum for a, like, very large numbers. It means like this one have more recursives, more repetition within the function. Definitely, somehow this will give the answer. But now, currently, no. In your, like, extreme question, no, it takes like timeout. It have a time. Within the time, you need to execute and get all those answers. So what happened? This is right. The code is right, 100% right. But the thing is, you need to think in different way. You need to approach to this a different way. Okay. So we need to find out the answer with dynamic program. So that again, the same thing, the previous views, like we have, like, these, like, wait, just, so these two are same. I think you familiar with this. 2 by 3 and the 3 by 2 are the same. So we are going to use the same thing here. How? Like, you will see 1, 8 is the 0. Zero less mean like 0 columns and 3 0 columns and 3 0 rows and 3 columns. So the answer will be 1. Again, in here, the answer will be 1 too, like 0 column and 0 rows and 2 columns. 1 mean, like, again, it not. So this is the grid traveler 1, 2. So this one gives the grid traveler. Again, this is the grid traveler 1, 2. Again, this is the grid traveler 2, 1. But the thing is, the value of this, these are all the same. Okay, now you think, okay, so we are find out few like similar patterns, and those are same. What happened? We need to memorize those values. Like, don't think about the programming when you write this kind of code, like how to find out. Just find out the pattern. So there is a base case in here. Beside the base case, we have something in here we can memorize. So if you memorize those parts, it will be, we can optimize this with dynamic programming. I saw something in here. Just give me 1 second. So this one is still running, yeah. Since we put 90 and 90, you can see the time. So 3 minutes and 13 seconds. The code is right, but still running. What happened? What to do? Dynamic program is the thing is you need to do. So this is the optimum code. In here, definitely you need to handle those base cases. These are, we call this as a special base cases. So you need to handle. I think you know this is. But the thing we add that part is, I think I like when comparing this to the previous question, I think like you will see like these all have the same pattern of some kind of stuff. Like same stuff. These are not the same questions, but the patterns you can recognize those. It's all about the pattern recognize. So in here, what I'm going to do, we make a memory and we're gonna store the values. That's the thing, like that's the ultimate thing we're gonna do. And we need to store those values. If the result is already calculated, return it from the memory. If the result we have, we don't need to calculate it again. By using the memo, we can get the thing by using the keys. And these are the calling. This is how the calling the functions. Again, you don't need to practice like coding. You will need to have the basic coding knowledge, but the thinking is the ultimate stuff. So you can find out those stuff. Means for the extreme, you can like go as a team. If someone is more good for the math, so that they can identify those, just go with them. The programmer can definitely program those. Like, nowadays, programming is not the harder part. Anyone can, most of the time, anyone can program it, but the thing is better. Okay. So we have the answer. This is the code. Just give me 1 second since the previous one is running. I stop in here. Just give me a second. We cannot find out for the 99, but by using 99, I think yes, the previous one is good. Can we try 30 by 30 here? Let's try out 30 by 30. You get the answer. We can try 90 by 19, but it takes few time. We have time. We can test. Yes, with a zero. The previous, the same thing, the previous, without the memorization, it took like, even the with the like more than 4 minutes, more than 3 minutes, didn't give the answer. But since we have the memorization, it gave the answer. Okay, we completed our second question. You will get this document as like reference document. So I was made this to like encourage you like few graphs and all of the stuff. So you can go through with that like once you will get, these are the like another questions, another popular questions like NPM and number of islands. Like these are the very famous questions. So you can go through with that. This document will be shared with you like once like there is a time in here like after the questions and all stuff. Definitely you can go this document too. Okay. Now the time for the third question. Again, I'm going to use more Fibonacci. Okay. But this time it is little bit different. It's one thing. The zeroth number of the sequence is zero. The previous one, the zeroth number of the sequence is one, and the first number of the sequence is one. Again, you know this, like how you have very confident. Right? You don't need to worry about this one. This can be considered as a special base case. So by using the older pattern, definitely you can go with this. But can we try out another method for this? Seems like this have a pattern like there are no common thing. And the previous stage we have 1, 1, 2, 3, 5. Now we have like 0, 1, 2, 3, 5. The same pattern, but like we have first we have 0 and 1. Like, is there a way for the build out those stuff? Definitely you can try to be a special case and go with the previous one. Definitely, but this is the thing. Okay. The third one, we are going to use tabulation. You can see this is sort of an array. So these are the, like for the demonstrated purpose, I only get the 8. Value 8, it means like only 6 point. Like it means like 0 to 6 point. I mean, like first one will be considered 0, 1, 2, 3, 4, 5, 6, likewise. So so this is our base case, right? This is we gonna build up. So you know, let's find out the pattern. 0, 1, 1, 2, 3, 4, 8. So how it gonna do? So we have a hint in here. In here we had a hint. To generate the next number of the sequence, we sum the previous two. We already have the hint. We have the hint. Okay, what I'm going to do, I put all zeros in here. So we have the 8 length of one-dimensional array, and I put all zero in here. And I know the first value is 1. This is the first value is 1. So what I'm going to do to get the sum of this and add it to the next, consider as box. Next box, you can do it. So what I'm going to, now you will see 0, 0, 1 and 1 plus 0, 1. The next step is again 1 plus 1. It need to be assigned here. Like 1 plus 1 means like, what is this? It need to be print as 2. Now you get the value 2. When it comes to here, what is 1, 2, and you will be see as 3. Since 1 plus 2 is 3 in here. 2 plus 3, it will be considered as 5. Again, 3 plus 5 considered as 8. You can go more through with this. So this is the thing. But you will find out the pattern. So you think like, this is the pattern. This is the pattern in the. So what happened? The same thing, but you're gonna make, if the n is 0, you need to return 0. We consider in that ways. The rather than using previous way, we gonna use an array. What we are doing now, we're gonna use array. So there is some sort of a difference from the previous one. But like for the previous one, we try like typing, I think 300, I think. Definitely we can get it to there too. At the beginning of the session, I was told like sometimes one single question have some sort of method, and like, there are a lot of ways to type the code. So again, by using this method, you can find out the answer for the first example. Definitely you can. Again, you need to like modify the previous, like modify the cases. But the ultimate thing is what? The ultimate thing is like which one is better when comparing to the long term. In here, you will see like in the, definitely there is a recursive in here with the another recursive in here and another recursive in here, and it need to be append, and again it have a sort of like iterations, and it's fine. You need to try out those. Okay. Okay. We done our example, third example. Let's move on for the fourth example. Okay, like the same thing. No. This is similar to the second example. 2D grid. How many ways to travel in menu? You can move down, move right. Again, the same thing. Like you think like whatever, like he sort out this question. I was giving the same question again and again. As I mentioned before, we have a lot of ways. We need to find out the optimum. All the cases we give the answers. That is the beauty of the dynamic programming. We need to find out which one is better with the space and the time. It's all about the space and the time. So, okay, you know the question, I think. We have a 2D, you are in the top of that. We need to make the trip travel. So let's move on further. So now what I'm going to do, like for the second question, for the third question, I was using a 1D array, like a one-dimensional array. So now what I'm going to do, I'm going to use like 2D array. Again, I'm going to use the same thing. It means like we have 3 by 3 grid in here. So you know with the experience, so for the 3 by 3 grid, definitely it has 6 space to travel. So this is how I am going to make my grid travel. This is called like the tabulation, some sort of a tabulation. So basically we call this as, majorly we call this as a grid. So what I'm going to do, I need to add the extra layers in the tab. This is for the first, you can consider as a column, second column, third column, and this is for the first column, second column, and third column. But I am adding an extra 0th layer. So all are 0. Why? You know, if a grid traveler have the 0 row, either 0 or either 0 column, the value is 0. That's why I was marking these all are as 0. And you know the next case also. If the number of columns and the number of rows are equal 1, you only have one way. This is one way. So this is the way we're going to sort out this problem. One second. So what we are going to do, we need to do additions. So how we going to do additions? We are going to travel through this grid. That's why we call this as grid travel. First of all, we need to travel by here. How to get it? 0 plus 0, what? 0 plus 0, 0 plus 0, 1. 5 plus. Go. Addition. Wait. I'm going to look at like how I'm going to show these value to you. Okay, likewise this. All are 0, now 0, 0. It's like adding 0 to here and here. Again, adding 0 to here and here. Adding 0 to here and here. Adding 0 to, there is no way, and here. Let's come out to this, adding 0 to here and here. No value. Adding 1 to here and here. Now what happened? This one will be 1 and this one will be 1. I'm good. Now again to here. Adding 1 to here and here. Again, adding 1 to this, because this is 1, here and here. Again, you need to come to here. You will see adding 0 to here and here. Nothing different. Adding 1 to here and here. So you will get 1. And this is as 2, not 1. When it comes to here, adding 2 to here and here. So this will be 2 and this will be 3. And when once you come here, adding 3 to no, there is no one in here and here. So it should be like this. By going through that way, you can fill out the entire grid. This is the second way. And this is the third way. After that, you will get 6 as an answer. Definitely you will get, since you know that 6 is the answer, definitely you will. So the same thing. Now what we gonna do? Like we remember this. Like we need to remember the value and we need to adapt to those three values. Again, we need to remember this value and we need to adapt those three values. As like likewise, we need to travel grids, grid values. So this is the way. See, you guys see the code. This is how we can memorize those stuff. For the memorization. We are using we use a sort of table. Like, since we have columns and rows. We name is at a table, but there's a technique in Python. So again, let's try out 90 by 90. You will get this kind of like very big number. Definitely, this is also right. So like as a homework, like a homework. So for the same problem, it's a little bit different. We learn a lot of stuff. So as a student, you need to know again. Once you reach out to the home, you need to like say we learn two techniques for the same answer, but those are the same, right? Now those are more powerful since we learn like which one? Recursive with memorization. Also, we learn the tabulation, and we learn the differentiate between the space. And so you need to think about like, okay, which solution is most appropriate, and we have very large definitely when it comes to 10 by 10, definitely it working. The next thing is like, assume like you get like you need to find out first 3 Fibonacci numbers. Don't write code like this. The thing is you need to find out first 3. by using very small code, you can do it very easily rather than like doing all the memorization and all the stuff. I can say like this, like even if you have a like very large excavator, don't use it for the like plant a small tree. So you need to think about it. Majorly when it's come to the extreme question, it's like these are the beginner level extreme question, very beginner. You need to all the questions will starting with these case cases. Okay. So with the time limitation, I think I don't have much time to cover up the grades. So let's go for a few breakout session. I think the session breakout will be go under 5 minutes. You have questions, so I will explain the question. I think you guys are pretty familiar with tic-tac-toe. You are pretty familiar with tic-tac-toe. Like someone now put like zeros and the other one now put X. This is a tic-tac-toe. Like some people call like zeros and rows. This all are right. So what happened if someone put, let's put like crosses. Someone put like this, definitely he will be win. Oh, someone put like this, definitely he will be win. You know, like somehow you need to put X values either row wise or either column wise. Or you can use X for the diagram. But it's a little bit easy. So the question is, how you gonna do? You need to discuss with your groups once the breakout is like going. You need to discuss like you need to discuss and come out and type how if you're going to make an AI. So this is not AI, this is a logic. We can call this small things as AI, but this is a logic. What is the logic behind that? If you need to have a built a solution to win this match, what is your uh, solution? How you gonna win that? Definitely someone playing against you. You are putting excess. So how you gonna win? And like to easier the question, so you are the second opinion. So the first one is put zero in here or here or here. You are putting the excess. So okay, let's break out the rooms. Like 8:50, I will start to demonstrate. Yes, like once the breakout is done, you must join for the main session. Other don't go and leave, like just join for the main session. Okay. Seems like the breakout room like allocation is like it have a, like seems like there are a lot of people in here. So rather than going for the breakout, I think the session organizers will be uh, available, will be give you the access to the mic. So can someone demonstrate what is your approach? So yeah, it doesn't matter. I'm not asking the code. So what, how AI, like, but how your program will be interacting. So you have this kind of a board. So assume the first one is put 0 in here, all 0 in here, all the 0 in here. What is your winning strategy? Can someone explain? I think you all have the mic permissions now. I'm just not asking the code. It's only the basic, just think how you're gonna win this kind of a scenario. I make easier, like you are the second one, so you can think about like, okay, now I'm going against to the first opponent. Like you can think about definitely some kind of a data structure involvement to making the program, but I'm asking the logic. What is the basic logic in anyone? I think you all have the mic permission. You can turn on your mics. So what happening here? Okay, I will little bit explain. So in the base case, so if you plan to win this kind of message, this kind of tic-tac-toe, you can just Google and this will be a fun activity. Tic-tac-toe. Google Chrome have an inbuilt tic-tac-toe. Like, so just give me 1 second. So this is the inbuilt tic-tac-toe. So what I'm going to do, if someone put X here, so sorry. So if someone put X here, so what my winning plan is like, so I can put 0 in here. But the thing is, if I put 0 in here, so this path is blocked. Definitely here put X in here. So in here or here. Because the 0 is like not much valuable for me. Like I only have one path when I am putting 0 in here. But when he putting X in here, he have 3 paths. Here, here, and here. Even though definitely I need to put 0 in here, definitely he will put it. Whatever. Put here. No one can't here. So I think this is the center is the better way for the optimum. So we need to cover up this part. And again, the second counter you can put in here, but to win, the second best option is putting zero in here, not here. But you will see these kind of things like as I told you before. Like they are impossible, not like the AI. Like, this is not AI, the simple program, but AI is working well. So you can try out those stuff, even though I'm not giving the full answer. And you will have more solutions. You need to find out like the diagonals and for the rows and the column solutions. But when you are writing those stuff again, you will find out few interesting things like this 3 by 3 grid. So you can turn around the grid and you can get few sort of stuff rather than find out all the solutions. Like I'm only giving the hint. So you can try out those stuff. So my time is up. And again, thank you again for joining the session, and thank you again inviting me to conduct this session in this year. Like, I'm really happy there are a lot of participants, like more than 50, I think 60 participants in here. Like, really, thank you for coming. And I'm giving this to like Algo team. But in the meantime, if you have questions, you can reach out to me too. Thank you.
All right, we're now moving to the Q&A session. If you have any questions, feel free to drop them in the chat. If there are no questions, we'll proceed to wrap up the session. Before we wrap up, just a quick note on attendance. We'll be sharing the attendance form right after the quiz. Please make sure to use the same name across Zoom, the attendance form, and the quiz. This is important for checking your performance and issuing digital credentials. If your Zoom name is different, kindly rename it now. Only the submitted forms will be counted for attendance. And before we move on, we would like to sincerely thank our speaker, Mr. Madhushan Ilangakan, for taking the time to share his knowledge with us today. It was a very insightful session. As a small token of our appreciation, we'd like to present this in recognition of your contribution to Algo Ace 2.0. Now, coming to the session challenge. The quiz for this session will go live right after this. It will include 10 MCQs based on today's content, and it will be open for 1 hour only. Please make sure to use your registered name when attempting the quiz. To keep things fair, we'll be cross-checking quiz responses with the attendance details before final evaluation. Your performance will directly contribute to your overall ranking and badges. Before we wrap up, we'd like to share an important announcement regarding the Algo Ace 2.0 final quiz. The final quiz will be held on tomorrow, 26 July 2026, from 10 a.m. to 11 a.m. It will consist of 15 MCQs covering content from all 4 Algo Ace sessions. Your performance in the final quiz will contribute to your overall Algo Ace ranking and will also be considered when awarding digital credentials and recognitions. Please note that only 1 attempt is allowed per participant. If multiple attempts are made using different quiz links, the participant will be disqualified. We encourage everyone to revise the concepts covered throughout the series and do your best. We look forward to seeing your performance in the final quiz. Best of luck. And finally, thank you everyone for joining and staying engaged throughout our session series. We truly appreciate your participation. Please don't forget to complete the attendance form and attempt the quiz. Looking forward to seeing you all again with Algo Ace 3.0. Have a great evening. Thank you.